all, I'm Dipinti Manandhar and today I'm going to give a short presentation on the paper entitled Providing Bandwidth Guarantees, Work Conservation and Low Latency Simultaneously in the Cloud. The authors of this paper are Shuhai Hu, Wei Bai, Kai Chen, Chen Tiang, Ying Zhang and Haito Wu. The link of the paper can be found here. We all know that in today's cloud, it is very easy to share the computation and storage resources effectively among multiple tenants. Tenants means the person who pays the rent for the network resources. But sharing the network resources with bandwidth guarantees is very complex and challenging. The tenants may experience various network performance which can adversely affect their application performance and increase its cost. Even though when the users specify the amount of bandwidth they need, if they don't fully utilize their share, then it results in bandwidth waste. Therefore, the cloud network should also provide the work conservation along with low latency for enabling the multiplexing economic benefits for the cloud providers. There are also issues like how to handle the packet trapping of the work conserving traffic, how to deal with the possible packets reordering. Therefore, to create a cloud network design where all of the three objectives are met, Trinity is designed. It is a simple network support which is able to solve the problem. The Trinity model is able to solve issues like packet trapping, packet reordering. Before describing, let me explain about the Trinity model. It runs on the hypervisor layer and has two parts. A rate controller module, which is responsible for determining the traffic rates for bandwidth guarantees, and work conservation for each virtual machine and number of virtual machine to virtual machine channels to decouple, providing bandwidth guarantees from being work conserving by using two buckets which generates green and red tokens. So, firstly, to avoid packet trapping, the hypervisor will estimate the fraction of explicit congestion notification incoming packets for every virtual machine to virtual machine channels periodically and sends message to inform that it does not receive any packets. The number of packets received at the sender side is checked. If the source virtual machine does send out some red packets, it indicates the packet trapping in the network. Then it is marked as congestion caution channel and the work conserving rate is set to a very small value. Secondly, for solving packet reordering, two-folding is done. A transition delay is introduced to alternating flow of the red packets to green packets. This decreases the chance of packet reordering. Lastly, for the rate controlling problem, the rate controller computes bandwidth guarantees rates and work conserving rate by adopting an aggressive algorithm. Now let's discuss about the novelty section. What's novel about this paper is that the proposed Trinity model differentiates traffic at the end and enforces prioritization in the network. The authors have emulated multiple virtual machines by creating multiple virtual network interfaces with different IP addresses for avoiding virtualization overheads. All the packets are defined as bandwidth guarantee packets and are given higher priority for achieving low latency for short flows. The author have introduced a novel method called in-network prioritization, with priority queuing to eliminate the trade-off between bandwidth guarantee and work conservation. A novel approach for making it scalable is low CPU overhead are introduced to servers, which is capable to do fine-grained rate control with small addition CPU utilization. Due to this, the rate of virtual machine can quickly adapt to varying network condition and converge within a few milliseconds. Let me explain about the schematic diagram. There is a sender, network fabric and receiver side. At the sender side, to decouple providing bandwidth guarantees from being work conserving, two token buckets are used. Token bucket 1 generates tokens at the rate of Rg, while token bucket 2 generates the token at the rate Rw. The generated tokens are fed to the rate limiter for performing rate limiting. To achieve low latency for short flows as introduced, Trinity only needs to color all the packets of short flow as it is, and then receive higher priority in the network. Therefore, a classifier module is employed in the virtual machine to virtual machine channel to assign each flow to either a short flow buffer or a long flow buffer. Only green tokens are fed to the rate limiter for short flow buffer. This is to ensure all the packets of short flows receive higher priority in the network. For packets in the short flow buffer, they only consume tokens in the token 1 and enjoy the low latency in the network. In case of token bucket 1 runs out of tokens, the packet just waits temporarily for the new green token to be generated. When there are available tokens in the token bucket 1 and short flow buffer is empty, then they are colored as green and identified as bandwidth guarantee traffic in the network. Otherwise, they are colored as red and identified as work conserving traffic. Although the paper has introduced a framework where all the three objectives are met, there are some critics. When the network manager is not able to update the tenant abstractions, their placements after each reconfiguration, it is not able to provide all those three properties. For detecting the unused bandwidth, the flow rates is increased. Due to this, there is underutilization of available bandwidth when less probing is done. But if there is frequent probing, then it affects the bandwidth guarantees of other tenants when their traffic come back to network. Due to this, work conserving is not satisfied. The rates increases slowly in the beginning, and as soon as it senses congestion, it drops dramatically. Due to this, the spare bandwidth is wasted. A large number of packet loss can be caused due to sending too much work conserving traffic in the switches. As a result, there is timeout of TCP and its throughput is affected. Scope of improvement. For balancing the network load across multiple CPU cores, the author have mentioned to implement multi-core await Trinity in the future. A different method should be used so that the network manager will be able to obtain the tenant abstraction. The proper management of spare bandwidth must be done so that there is constant flow of the rate. Since static reservation provides a minimum bandwidth guarantee, but does not utilize any spare bandwidth. Thank you.